Like in timer TF0 and TF1, it will be automatically reset. But in serial communication, we have to reset it manually. So when there is a TI and RI, so when data is transmitted or data is received, so at that particular moment, this flags will be set. So we will go to this routine. On this routine, we have written the address or we have written the instructions related to this serial communication. So in this service routine, we have to manually reset these bits. So that is for serial communication. This is for timer 0, timer 1. This is for external interrupt. If you want to handle external interrupt, so external pins are there. These external pins are available with port 3. So 2 pin from port 3 we are using as an external interrupt. So in external interrupt 0, external interrupt 1. So when external interrupt will be received, this flags will be set and we will say that this interrupt is generated. When we will start interrupt service routine, then this particular bit will be reset. So that is about the interrupt, and this is the reset interrupt. So when there will be the reset, when we will press the reset, then O it will be jumped to by default. Which location? So vector address will be 000. We will discuss this reset interrupt in next slides. That when in controller will be reset, what are the states of your different special function registers as well as flags? What will be the content inside registers as well as different flags? उसके अंदर क्या क्या होगा? So that we will discuss. And when we will press reset, after reset, what will be the state of your controller? So upon reset, all interrupts are disabled. So when we will press reset, by default, all interrupts are disabled. And so immediately after reset, if any interrupt will be generated, it will be not handled. Why? Because we have to, first of all, enable it. So interrupt must be enabled by the software in order for microcontroller to respond them. And there is a register. So इसको enable करने के लिए हमारे पास कौन सा register है? There is a register called IE, interrupt enable, that is responsible for enabling, or you can say that enabling or disabling this. So this is an interrupt enable register. So this is your interrupt enable special function register, in which we are having 8-bit 0 to 7. This is our master bit. We can say that if this is 1, then and then only this will be affected. If this is 0, then there will be no effect of all these bits. So this is enable bit, EA. Bit number 7 is enable bit. So enable interrupt bit clear to 0 by a programmer to disable interrupts. So if you want to disable all the interrupts, then we will make this 0. And if you want to enable a particular interrupt, so set to 1 to permit individual interrupts. Individual interrupts को permit करने के लिए अगर आपको allow करना है, so we will allow it. So by making this, and let's say that this is a 1, so what we are doing, we are allowing only this interrupt. That is a external timer 0. What is the interpretation? How we will read this? So यहाँ पे इसको कैसे read करेंगे? So this is our 0th bit, which is EX0. So that is external interrupt 0. So जो external interrupt जो आएगा उसको आपको handle करना है या नहीं करना है? The external interrupt which will be provided to your controller, whether you want to handle this external interrupt or not. So that will be decided based on this bit. If this bit is 1, then we are allowing it. If this is 0, then we are not allowing this. So external interrupt bit set to 1 to enable this and clear to disable this. Same way, this is for Bit number 2 is external interrupt 1. This is for external interrupt 1. Next, timers. So when timer will be overflowed, so timer overflow interrupt. So this flags whether you are allowing timer overflow interrupts or not. So if this is 1, then and then only timer overflow interrupt will be handled. Otherwise, timer overflow interrupt will be not handled. तो यहाँ पे 0 होगा तो इसका इंटरप्रिटेशन क्या होगा? What is the meaning of this? It means that even if your timer will be overflowed, it will be set your flag, but that flag will not generate interrupt. It will be not considered as an interrupt. That is timer 0 and timer 1. And this is for serial communication. So whether that's SINTI, transmitted and received, RINTI. So whether this interrupt should be handled or not. So that is a serial port interrupt that will be decided based on this bit. And this is not used. It is, we are not using this. This is reserved for future. So we will generally keep this both bit at a 0 0. Now, if I want, I will say that using instruction, what you need to do, you need to turn on external interrupt and you need to turn off your internal interrupt, your, you can say the timer interrupt. So आपको यहाँ पे क्या करना होगा? What you need to do, enable external interrupts. So external interrupts को on रखना है and disable internal interrupts. So what should be the value over here? Which bit we will keep 1 and which bit we will keep 0? So according to this, external interrupts are this. So we'll keep this both as a 1 as well as ये जो serial communication के bits होते हैं वो भी serial that are also known as external interrupts. So these 3 you want to make it as a 1 and these 2 I want to disable and these 2 are not used. And what should be the value of 7th bit? 7th bit की value क्या होगी? It should be 1 to make this effective. Okay, so this should be there. This value we have to load in which register? In this special function register to enable interrupt. And this is a bit addressable. It means that individual bits को अगर आपको on off करना है, so we can do this by some instructions. We are having these instructions. I will demonstrate use instructions also. So IE0, you will generally use it like this, IE0 or IE1. So if you want to enable or disable this, so यहाँ पे instruction होगी set IE0, so it will make it 1, or you can say that reset, or you can say that's clear. So according to that, we are having instructions. We will see a few of the instructions related to controller. So this is about the special function register, IE, interrupt, enable. Okay. So this is about the interrupt. And yes, what is the priority? If more than one interrupt will be generated at the same time, then which interrupt should be solved first? So external interrupt 0, this is a priority. It is having the highest priority. External interrupt 0, so we are calling generally IE0. इसको generally हम क्या बोलते हैं? IE0. So external interrupt 0. Then timer flag. So ये जो timer 0 है, so there is a timer 0. Then IE1. So this is the default priority. That by default, this interrupt will be handled. If simultaneously, if timer 0 and external interrupt are generated, then out of these 2, which will be solved first? This should be solved first. And when there will be the lower priority interrupt is there in execution, higher priority interrupt will be generated, then we have to handle that higher priority interrupt here. So higher priority interrupt can also interrupt your service routine of lower priority. And if you want to specify the priority, then we can specify the priority also. So for setting a priority, we are having this interrupt priority special function register. So in this interrupt priority special function register, these two bits are not used and remaining bits are related to your interrupts. So bit will be 1 or bit will be 0. So if particular bit is 1, then it is having higher priority as compared to bits which are having values 0. So if you want to provide higher priority to, let's say, that serial communication, we will make this bit as a 1 and we will keep all other as a 0. So यहाँ पे 0 का मीनिंग उसको डिसेबल नहीं करेगा, इसकी प्रायोरिटी लो करेगा. It makes its priority lower as compared to serial communication, serial port interrupts. So let's say that we have sent, so this is for external interrupt 0, this is for external interrupt 1, this is for timer 0, this is for timer 1, and this is for serial communication interrupt. And this is also not in use. So we are not using this 3-bit, and remaining 5 bits will use for our this respective interrupt. उसकी priority है उसको set करनी है. So let's say that we have set this to priority. We have set this 1 and this is also 1. So what is the interpretation? Interpretation will be over here that if this any of this 1 will be generated, that will be treated as a higher priority as compared to this remaining 3. External interrupt, by default this is having the higher priority, but and this is having the by default this is having higher priority, interrupt 0, and we are assigning now higher priority to this timer 0 and timer 1. So ये दोनों को अब higher priority आप assign कर रहे हो as compared to rest of the 3. And again, if there will be this both interrupt will be generated at the same time, then what will happen? टाइमर 0 एंड टाइमर 1 में भी अगर वापस दोनों एक साथ जनरेट होंगे तो then this priority will be followed. Then timer 0 and timer 1, वो दोनों में से किसकी हाई प्रायोरिटी आई है? Timer 0 and timer 1, this priority is having higher priority as compared to timer 1. So that is how we will calculate or how we will use this priority bit, or you can say that's IP, priority interrupt priority special function register, and IE, interrupt enable special function register. This is related to interrupt. Is it clear? यहाँ पे कोई query है? Do you have any doubt related to interrupt? IP, interrupt priority special function register, is just used to specify the priority as compared to others. So out of 5 interrupts, which interrupt will have higher priority? It is not for enabling or disabling interrupts. Enable disable करने के लिए IE, interrupt enable special function register, and this is also bit addressable. We can address it individually. So individually bit को आपको set करना है, reset करना है, we can do this. And this is what I was talking about, the reset. So when we will press reset, so reset cannot be avoided. It means that you cannot avoid a reset. आप यहाँ पे देखोगे, so I have listed out these interrupts. How many interrupts are supported over here in controller? 1, 2, 3, 4, 5, and 6 interrupts are there. So out of the 6 interrupts, this is non-maskable, and rest of the interrupts are maskable, which you can avoid, which you can disable. But this reset we cannot avoid. So reset is non-maskable interrupt. And when we will press the reset जब आप पिन को 1 करोगे, when you will provide logic 1 to reset pin of our controller, your controller will be reset. And what will be the status of program counter? So program counter will become 000. Same way, what will be the status of DPTR? So it will be again 0. What will be the status of your A and B or general purpose register? It will be again clear. And same way, our RAM, internal RAM will be also, it will be internal RAM that will be clear, or there will be random content will be there, because RAM whenever you will power off, so that means over here reset जब करोगे तो आपका कंटेंट जब जो भी है वो रिमूव हो जाएगा. Then what will be there in PSW, program status word, वो भी क्या हो जाएगा 0. What will be the stack pointer? So that I have already told you that when we will press the reset, this is important, this you need to remember. What will be the, ये सब कुछ आपको याद रखना है, but this is a special case that when we will reset the stack pointer, so stack pointer value will be 07. So by default आप reset के बाद stack pointer की value क्या होगी 07. And when this reset pin, so यहाँ पे मैंने आपको यहाँ पे indicate किया हुआ है how to reset this. So to perform a reset, apply high level to RST pin, and when this level will become low, then internal register will have the values as per this specific. Port 0, port 1, port 2, port 3, we are having 4 ports. So what will be the status of all 4 ports? So all 4 port will be 1111. So it means off. सभी ports क्या होंगे 111. What will be the status of your interrupt priority flag, interrupt priority special function register? It will be 0000. Same way, what will be the interrupt enable? So जो अभी हमने discuss किया that it will be disable all the interrupts. So सभी interrupts है वो क्या हो जाएंगे disable हो जाएंगे. What will be the tcon t mode special function register? Your timers, so this is a timer 0, high low, timer 1, high low, serial communication, scon, s buffer. So buffer will be again don't care, and scon will be 0, and power control, so s mode bit will be 0. So pcon register will be again 0, and then don't care. यहाँ पे b का इंडिकेशन क्या है? दिस इज देयर इन बाइनरी, ये बाइनरी में इंडिकेट कर रहा है. So internal RAM content will be random. Register bank 0 is selected. That is again important. Which bank will be selected after reset? Register bank 0 will be selected after reset. And PSW will be 0. Stack pointer will be 07. These are the things you need to remember, that what will be the status of your controller after reset. It is end of this chapter related to controller. We have seen pin diagram, we have seen internal architecture, we have seen special function registers, functionality of each and every special function registers, how to do serial communication, how to use interrupts, how to generate, how to use timers. So do you have any query in this particular chapter? कोई question है? I will upload this slide after this lecture. Lecture complete होने के बाद मैं slide upload कर दूंगा. Okay, so shall we start with next chapter? यहाँ तक सब कुछ clear है? Okay, so let me open the PPT for our next chapter. So our next chapter is related to addressing mode. So over here, what we will do, we will learn addressing modes with reference to data transfer instruction. In our microprocessor, We have learned that instructions can be data transfer instructions, instruction can be arithmetic instructions, instructions can be logical instructions, instruction can be program control instructions. So we are having different types of instructions. So same thing in controller also we are having instruction set which contains different types of instructions. So first we will see data transfer instructions, and in specifically data transfer instruction we will use move instruction. But so there are other instructions also. Arithmetic instructions are also there. Logical instructions are also there. Program control instructions are also there. Also there, but it will be almost similar. वो हमारे जैसे माइक्रो प्रोसेसर में जो हम इंस्ट्रक्शंस लिखते थे वैसे ही यहाँ पे भी सिर्फ थोड़ी बहुत मेमोनिक्स जो है वो चेंज होते हैं. Otherwise, functionality will be same. Logical and logical or rotate right, rotate left, add, subtract, all such instructions are there. So over here, we will try to cover as much as possible instructions in our syllabus. जितना हो सकेगा उतना हम consider करेंगे, and whatever instructions will be covered or whatever part portion has been covered, that will be there in your syllabus. जितना complete करेंगे हम उतना हमारे syllabus में होगा. Suppose because बाकी की instructions जो है वो आप simply read करके भी observe कर सकते हो. So our main focus is on addressing mode. हमारा main focus है अभी कौन किसके ऊपर है, addressing modes के ऊपर. So what are the addressing modes available in controller? So there are, you can say that 4 basic addressing modes and 2 advanced addressing modes. So we will learn this first 4 basic addressing mode. So addressing modes, that is a immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and this is, you can say that special addressing mode, that is for external data movements, and this is index addressing mode, that is for in ROM reading a data, or you can say that moving a data from ROM में से data move करने के लिए जो हम addressing mode use करेंगे. So first we will learn this 4 simple basic addressing modes, and then we will discuss about this 2 advanced modes over here. So first, this is with reference to which instruction we are going to discuss it, with reference to move instruction, data transfer instruction. So move, how this move instruction will work. So move instruction, what will be the format of move instruction? Move, and there will be next operand, that will be your destination, and this will be your source. So data will be copied from source to destination, and in this data transfer your source will remain unchanged. आपका source का data है वो as it is रहेगा. So that is fast addressing mode, immediate addressing mode. So in this immediate addressing mode, what we will use over here, how to indicate this immediate addressing mode. So immediate addressing mode will be indicated by this as sign, or you can say pound sign. So we will write instruction like this: move. ये R क्या indicate करेगा? What is the indication of this R? R means register. So move R0. Let's do that. Move R0 has, let's say that 55. So this will copy 55 in our register R0. So this is immediately, this is the direct data. So when this instruction will be converted, when such immediate address instruction will be converted in the machine code, so it requires 2 byte space to store this, because whatever is your operand, यहाँ पे जो होगा move dptr or move a or move R0, according to that it will convert it into opcode, ये opcode में convert करेगा, and this will require one more byte to store your data. ये आपका data होगा यहाँ पे. So this is move over here dptr, and then has I have written nn. So this is indicating that your data is 16 bit. So in this case it requires 3 byte. 1 byte for your opcode and 2 byte that is for your data. So in this case it requires 3 byte. In this other two examples it require only 2 byte. So generally instruction format, if it is like this, then you will, so कोई भी register यहाँ पे आप लिख सकते हो. Can I write instruction like this? Move has 90 comma R5. Can I write like this? Move has 90 comma R5. Can this immediate value be your destination? No, it cannot be your destination. So it will be always source. यहाँ पे ऐसा कभी possible नहीं हो सकता है. Okay, so this you need to take care. And if it is a 2 byte instruction, so we have already discussed this. How many machine cycle it require? It require only one machine cycle. Same way, next addressing mode, that is a register addressing mode. So register addressing mode, what we will do? The transfer will be done between two registers. So register, this will be your source and this is your destination. So register to register movement occurs between which registers? You can transfer data between this register AB and R0 to R7. You cannot write like this. आप यहाँ पे directly ऐसा नहीं लिख सकते हो. Move and tcon. Tcon is our special function register and scon is also our special function register. You cannot directly transfer data from scon special function register to tcon special function register. This register addressing mode in which we can transfer data between two registers, and those, what is the limitation or what is the set of this register. यहाँ पे आप जो register use कर सकते हो उसका set क्या होगा? It will be register A, it will be register B, or it can be R0 to R7. And this whole instruction will be converted in only 1 byte. ये पूरी instruction एक ही byte में convert हो जाएगी. So this is your only 1 byte instruction. So it will require only 1 byte to store your opcode. So, and that's why it require only one machine cycle. So that is a register addressing mode. So what is the main point over here is, this is the limitation. Register to register we can move a data, but your source and destination both should be registered. दोनों register ही होने चाहिए, and it should be either register A, register B, or R0 to R7. Now my question is, let's say that I have written move A and then R5. So it will transfer data between which we are having 4 register bank. Register bank 0, register bank 0, bank 1. We are having bank 0, bank 1, bank 2 and bank 3. So which bank will be used over here? R5 register होगा वो कौन सी बैंक का होगा? Which R5 register will be selected? Whether this R5 will be from bank 0, it will be from bank 1, it will be from bank 2 or bank 3. बैंक क्या है वो तो पता है ना? बैंक 0, बैंक 1, बैंक 2. यहाँ पे ये जो हमारे पास है बैंक जीरो, बैंक वन, दिस इज बैंक जीरो. Bank 0 will also have R5. Bank 1 will also have R5. Bank 2 will also have R5. And Bank 3 will also have R5. So if we have written instruction move A, comma R5, then from which R5 it will select data? कौन सा R5 select होगा? Bank 1. How you can say that it will be Bank 1? Yes, very good, Murtuza. It will be from PSW. PSW में से आपको पता चलेगा what you have set in your PSW. There are two bits available in our PSW. PSW में दो bit है, which will indicate that which bank is there in use right now. So that we have already discussed that PSW हमने discuss किया था that in this PSW, based on this PSW, we are having two bits which will indicate that this is your बैंक जीरो, बैंक वन, बैंक टू, विच बैंक इज देयर, कौन सी बैंक है, वो कहाँ से पता चलेगा? इट विल बी सिलेक्टेड बेस्ड ऑन दिस PSW. दिस इज द PSW फॉर्मेट. सो बेस्ड ऑन दिस, ये दो बिट है, दिस टू बिट्स आर देयर. Based on this two bit, it will give you information whether this R5 will be from bank 0, bank 1, bank 2 or bank 3. So by default जो होगा वो क्या होगा? So by default this is there. So which RS02 आपका PSW का वैल्यू क्या होगा? When there will be the reset, आप प्रोसेसर को रीसेट करोगे, your PSW will be also reset. इसमें 00 होगा. So if all will be 0 and bank 0. Okay, so this can be, so answer can be, what will be the answer of this question, that which R5 will be selected? So it depends on this two bit of our PSW, RS0 and RS1, and based on that it will select the register, your source register or your destination register. Suppose मैं यहाँ पे लिखूंगा, suppose if I will write like this, let me again go back. Yes, suppose if I have written over here, let's write move R3 comma B. So again it will be the same. So for source and destination, both will be same. Okay. Next, direct addressing mode. So in direct addressing mode, we will mention address directly. Previous case में हम क्या use कर रहे थे? What we were using over here, register, name of the register, like R0, like R1, like A. But in next, this direct addressing mode, we will not use R0, R1. What we will use? We'll use address. So as we have already seen that we are having four banks. So this is bank 0, this is bank 1, this is bank 2, and this is bank 3. So if you are using direct addressing, then there will be no confusion because each register will have different address. यहाँ से R0 to R7 होगा. What will be the address? We will indicate it by 0 to 7. Same way, this bank 1 will be indicated by this addresses. So if we will use by address, then there will be no confusion. But if you will use register name, at that time we have to go to the PSW and we have to check it. So direct addressing mode, we will use this direct addresses. Direct address use करेंगे. So these are the addresses that we already discussed. So this is the starting address. ये जो RAM है, ये diagram मैंने already हमने discuss किया हुआ है that this is a RAM. and RAM starting address bank 0, bank 1, bank 2, and bank 3. So 027, 82F, 10217, 182, 1F. So that is about the registers. And same way we have already seen about the SFR, special function registers. So these are the addresses for special function registers which we have already seen. So वो भी हमने already discuss किया था. 0E0, 0F0, then this is for data pointer. This is interrupt enable, interrupt priority. This P0, P1, P2, P3. This is for port 0, port 1, port 2, port 3. Pcon. So Pcon special function register, PSW special function register, S buffer, SCon, stack pointer, Tcon, Tmode, lower counter, timer 0 and timer 1. So we will use it like this. Look at these examples. So this is about the direct addressing. Direct addressing in which, so this is combination, you can say that. Direct and immediate. So we are using it over here. Move 90H has A5. So what is the interpretation of here? 90 क्या होगा आपका? What will be this 90? So based on this, you have to observe here. 90 यहाँ पे क्या है? So what is this 90? 90 is port address 1. So यहाँ पे इसका interpretation क्या है? That we are sending, data transfer will be to the port 0. ये port 0 के latch में हम data transfer कर रहे हैं. Same way, यहाँ पे इसका interpretation क्या होगा? We are transferring data to 3A. So 3A किसका address है? वो address 3A is the address of. So यहाँ पे आप अगर observe करोगे, so 3A will be the address of our RAM. 3A address होगा वो किसका होगा? 3A will be the address of our RAM. So this data will be stored in this location of your RAM. Same way, this is, we will write it. यहाँ पे हम इसको ऐसे भी लिख सकते हैं. This is just for indication that we have transferred data to port 1. So यहाँ पे हम address भी यहाँ पे transfer कर सकते हैं. So we can write the address like this also. So in direct addressing mode, generally we can transfer. अगर आपको address transfer करना है तो आप address यहाँ पे transfer कर सकते हो. So it will be in register A, and same way over here move address A. So move instruction, if you want to transfer data from specific. So if you want to select move A, let's say that 05. So इसका interpretation क्या होगा? Move A 05H. What is the interpretation of this? Move A 05. So 05 will be the which register? 05 होगा वो कौन सा register होगा? 05 will be the address of which register? 05 will be the address of which register? Yes, R5. So ये 05 होगा वो कौन सा register का address होगा? R5. So we are transferring data from R5 to A. Same way, let's say if I will write move 15H A. So it will transfer data from register A to 15H. But 15H is the memory location of RAM. RAM का ये address होगा. और RAM का ये address कौन से नाम से हम इसको we are calling it with which name? 15 address होगा वो किसका होगा? So if you will see it over here, then 15 address is of register R5 and bank 2. It is we are transferring data from A to this. Now, what is the size of RAM that we can use? Internal RAM की size क्या है? what is the size of RAM, internal RAM in our controller? कंट्रोलर है उसमें रैम जो है उसकी साइज क्या है? ये डायग्राम, based on this diagram you can answer that question. What is the size of internal RAM? Yes, 128. It means that 128 means what is the maximum address we can mention? We can mention maximum address. So our address can be 002 7F. Now, above this 7F, if you will use address, let's say that I have used move, and let's say that I have used 9F. A. Then what is the interpretation of this? So it will copy data from register A to this memory location. But if 9F is not the address of any special function register, अगर आप यहाँ पे 9F को ऑब्जर्व करोगे तो 9F है वो कोई भी स्पेशल फंक्शन रजिस्टर का एड्रेस नहीं होगा. Then what will happen? Then this instruction will generate error. So that is an important point over here. While using a direct address, if you are using address greater than 7F and that address is not the address of any special function register, then error will be generated. 7F and that not of any special function register, then it will result in error. But if that address is of any special function register, then there will be no error. Like over here, I have used 90, which is definitely greater than 7F. But ये 90 है वो किसका एड्रेस है? So 90 is the address of our port 1, so that it will not generate the error. Are you getting this? यहाँ पे आपको पता चल रहा है what I am trying to explain you. And another important point that you need to remember is when we want to mention the addresses, यहाँ पे मैं जब भी address mention करूँगा, let's say that if I will write move, let's say that E0 and F0. So I cannot write like this. I, because our first bit of address should start with be 0. 0 से start होना, or you can say that between 0 to 9 digit ही होना चाहिए. So you have to write like this. So whether this is a correct instruction or not, for that what you need to check is F0 to E0. So F0 will be the address of register B and E0 is the address of register A. So it means that we are transferring data from B to A. B से हम data A में transfer कर रहे हैं. So this is about the direct addressing. Okay, are you getting it? And do you have any question? यहाँ पे कोई question है? So direct address में एक ये point important है. This is the most important point. If you are using the address which is greater than 7F, so जो ये यहाँ पे मैंने examples दिए आपको बहुत सारे. And if that address is not the address of any special function register, then this instruction will generate error. Controller will generate error for such instructions. But if this address is of address for any special function register, and there will be no error. Your data transfer will be successfully. So we have seen three mode: immediate, register, as well as direct addressing mode, and then indirect addressing mode. So indirect addressing mode में हम क्या करेंगे? So in this indirect addressing mode, our address will be stored in one of the register, and from that address we will access our memory. So let's say that I have used over here, first of all, move R0 and then has 55H Now I am using this move at the rate R0 has, let's say that 50 or any such value, कोई भी वैल्यू आप यहाँ पे कंसिडर कर सकते हो. What will be the interpretation of this? That first of all, what is there in R0? R0 में क्या होगा? So inside R0 we will have 55, and that will be indicated to your RAM address. So RAM का address जो 55 होगा वो हम यहाँ पे @R0 as a use कर रहे हैं. So this will be your RAM address, and in this particular location we are writing data 50. This is indirect addressing. So register is used to hold actual data, and over here one limitation is there. Only R0 and R1 are allowed to form this indirect addressing. यहाँ पे लिमिटेशन क्या है कंट्रोलर में? इनडायरेक्ट एड्रेसिंग हम किसके साथ यूज कर सकते हैं? यहाँ पे आरपी लिखा है. सो व्हाट विल बी दिस आरपी? आरपी कैन बी R0 और R1. इट कैन नॉट बी R2, R3. उसके लिए यहाँ पे सपोर्टेबल नहीं है. सो यू कैन ट्रांसफर डेटा ओवर हियर. यहाँ पे आप ऐसे लिख सकते हो. यू कैन राइट लाइक दिस ऑल्सो, मूव @R0 and let's say that 80. So what will be the interpretation of this? 80 होगा वो क्या होगा? 80 will be address of any register, special function register. So 80 किसका एड्रेस है? आप यहाँ पे ऑब्जर्व करोगे तो you can observe it over here. So 80 is the address of our port 0. So what we are doing, we are transferring data from port 0 to the memory location which has been specified by this register. R0 में जो अपने 55 हमारा प्रीवियस एग्जांपल अगर हम कंसीडर करेंगे, R0 में अगर 55 है तो 55 मेमोरी एड्रेस पे क्या स्टोर हो जाएगा? पोर्ट 0 में जो भी डेटा होगा वो, पोर्ट 0 के लैच में जो भी डेटा होगा वो. सो वी कैन यूज इट लाइक दिस. इमीडिएट एड्रेस भी आप मेंशन कर सकते हो, पोर्ट का एड्रेस या रजिस्टर का एड्रेस भी मेंशन कर सकते हो. बट इनडायरेक्ट एड्रेसिंग के लिए आपको क्या यूज करना होगा? @sign. So ultimately this will be converted in 1 byte. तो ये आपका 1 byte हो जाएगा. This will be your 1 byte, and then whatever is your, let's say that if you are using both as a register, then it will be 1 byte only. But if you are using address also, then this will be of 2 byte, or direct data, then this will be of 2 byte. If you are using address, then it will be only 1 byte. So it depends. 1 byte होगा, 2 byte होगा, वो आप इमीडिएट एड्रेसिंग यूज कर रहे हो या डायरेक्ट एड्रेसिंग यूज कर रहे हो उसके ऊपर डिपेंड है. So this is combination of both direct address as well as indirect address. Okay, are you getting this? So this is about the indirect addressing. ये जो है वो indirect addressing. Next we will see how to communicate with or how to read data from ROM and how to communicate with external memory. Till this particular point, do you have any question? I will upload the PPT of previous chapter just after 10 to 15 minutes. I will upload it. So, do you have any question? Do you have any questions? At least reply so I can allow the students to leave. Okay. Okay, so today's lecture is over. You can leave the meeting.